Hello friends, today we are going to see about big data analytics presented by R.Sukumar. So we all have that one doubt, what is big data? Big data is all about handling a lot of information that comes at us really fast. It's not just about the amount of data but also about how quickly it's coming in and the different types of information that we get. So here what I can tell is big data is nothing but it is a soft concept for storing the large amount of data. Why it matters? Big data is important because it helps us to make better decisions. With so much information available, we can learn things that we would not have known before. This can help businesses understand their customers better, improve products, and even predict things before they happen. Now we go to the next slide. Now we see about the examples of big data. Examples. Think about all the things people post on social media, the pictures, comments and likes. There is so much of it that is not impossible to look at every single thing. That is big data. Lots of information coming in so quickly that it's hard to keep track of it all because we cannot handle large amount of data without using the big data. For example, if we take a Facebook, the Facebook handles billions of data at a single time, so we cannot handle them because we use big data technology for storing and maintaining this large amount of data. Now we will see about the four V's of big data. The first one is volume, second V is variety, third V is veracity, fourth V is velocity. The first V, that is volume. What is volume? Big data is characterized by a large volume of information. This refers to the sheer amount of data that is generated every second from various sources such as social media, sensors, and business applications. Managing such a large volume of data requires special tools and techniques as traditional databases may not be sufficient because we cannot handle large amount of data using traditional databases. For instance, think about a company that receives thousands of customer orders and interactions daily, generating an enormous amount of data that needs to be stored and analyzed efficiently. For example, if we take Instagram, we cannot handle the large amount of data using traditional databases because traditional databases can slow process for accessing and storing the informations. Now the second V, velocity. The aspect of big data emphasizes the speed at which data is generated and processed. With the advancement of technology, data is being produced and transmitted at an unprecedented pace. This can be seen in various scenarios, such as real time data from financial transactions, social media applications, or sensor data from machinery. For example, the continuous streaming of data from online purchases or social media interactions requires quick processing to derive meaningful insights in a timely manner. This is all about velocity. Now go to the next V, that is variety. Big data is not just about the quantity. It all encompasses diverse data types. This includes structured data like spreadsheet and databases, as well as unstructured data such as emails, videos, images, and social media posters. The ability to manage and analyze these various data formats is crucial for organization to gain a comprehensive understanding of their operations and customer behavior. This variety V is used to handle the all type of data. The first one is unstructured data, second one is structured data, third one is structured plus unstructured data. For instance, consider a marketing team that needs to analyze both text text-based customer feedback, and image-based social media posters to understand customer sentiment accurately. Now go to the next V, that is veracity. Veracity refers to the reliability and trustworthiness of the data. In the era of big data, ensuring data accuracy and consistency is crucial for making informed decisions. With data coming from various sources, there is often a need to assess its quality and authenticity to avoid any misleading insights. For example, a research institute analyzing climate data needs to ensure that data collected from different sensors is accurate and not influenced by any other external factors, ensuring the reliability of their climate models. So, in this, the fourth V is entered. Using these four V's, the big companies handles the large amount of data using the big data concept. This every V is responsible for taking every operations. Now we go to the next topic, big data tools. So we all know about big data. So how to use big data? We can use this big data concept using the sum of tools. The most popular tool is Hadoop. Hadoop, what is Hadoop? Hadoop is one of the most widely used open source frameworks for distributed storage and processing of large data sets. It includes the Hadoop distributed file system for storage and the MapReduce programming model for processing the data. Hadoop is known for its scalability, fault tolerance, and cost effectiveness, making it an essential tool for handling big data. Hadoop is nothing but it is a tool for big data concept. In this Hadoop, we have two main concepts. One is HDFS and for storage and the MapReduce for storage, and the MapReduce is programming model for processing data. Next tool is Apache Spark. Apache Spark is a fast and general purpose cluster computing system that provides in-memory data processing capabilities. It is designed for high-speed data processing and can handle both batch and real-time data. Spark offers a range of features including machine learning, SQL queries, and graph processing, making it a versatile tool for various big data applications. This Apache Spark is used by many companies nowadays because this Apache Spark gives many features for that including machine learning, SQL queries, and graph processing. Now the next tool is Apache Kafka. Apache Kafka is a distributed streaming platform used for real-time data pipelines and streaming applications. It is known for its high throughput, fault tolerance, and scalability. Kafka is famous for its scalability because every company needs to scale their from small to large. So Kafka is the best tool for large amount of data. Kafka is commonly used for data ingestion, messaging, and real-time data processing, making it a crucial tool for handling large volumes of streamlining data in real-time applications. Apache Kafka is used in many several industries using real-time applications. This Kafka is used by more number of companies whose you are using real-time data for customers. So this is all about the big data tools. This is some of the tools I have covered only some of popular tools. There are many other tools are available on the network. Now go to the next topic. So we have to see about the Hadoop in depthly. Definition: Hadoop is an open source Java based programming framework that supports the processing and storage of large data sets in a distributed computing environment. It was designed to handle massive amounts of data across a cluster of commodity hardware, providing a cost-effective solution for storing, managing, and analyzing big data. So this Hadoop is mainly used for storing, managing, and analyzing the big data. So every tool has main components. So just like that, Hadoop has two main core components. The first one is HDFS and the second one is MapReduce. Now we go to see about the HDFS. HDFS. What is HDFS? HDFS stands for Hadoop Distributor File System. It is a distributor file system designed to store and manage large volumes of data across multiple machines in a Hadoop clusters. That is, Hadoop HDFS is nothing but it is a distributor file system. It is used to store large volumes of data between multiple machines in a Hadoop cluster. Why we need HDFS? HDFS is crucial for storing and managing large data sets in a distributed computing environment. It ensures fault tolerance, high throughput access, and data integrity, enabling efficient processing and analysis of big data. So this is the importance of HDFS in many departments. Now we go to see about the HDFS in-depth diagram. In this, a system is separated into a 4 clusters. The 4 clusters have a large amount of data. These data are separated into a nodes. Now in this cluster we have two storage domains. The one is name node and another one is data node. First we will see about the name node. The name node is a critical component of the Hadoop distributor file system. It serves as the master node and is responsible for managing the file system, namespace, and regulating access to files by clients. It stores the metadata information about the files, such as the file names, file directory structure, and file permissions. This metadata is crucial for tracking the location of data blocks across the cluster. The name node maintains the mapping of the data blocks to the data nodes in the cluster, ensuring data reliability and availability through replication. It processes client requests related to file operations such as opening, closing, and renaming files, as well as handling client requests. This name node is mainly used for storing the metadata of the files. Now we go to the see about data node. What is data node? Data nodes are worker nodes in the Hadoop cluster that store the actual data blocks of the files in the Hadoop distributor system. They receive instructions from the data name node for storing, replicating, and deleting data blocks. So this data node is dependent by name node. Data nodes are responsible for reading and writing data based on the client's requests. So this data node is responsible for reading and writing data based on the client's requests. Data nodes send regular updates to the name node regarding the list of data blocks they are storing and their health status. This enables the name node to perform data block management and ensure data replication for fault tolerance. In case of a failure or loss of data node, the name node can replicate the lost data blocks to maintain data integrity. If data is stored in the data node, the data is stored in 3 different data nodes, because if the one data node is deleted or erased, we can access the data from the other 2 nodes. This is one of the features for data nodes. Now we have to move to the next topic, MapReduce. MapReduce is a programming model used for efficient processing in a parallel over large data sets in a distributed manner. The data is first split and then combined to produce the final result. The libraries for MapReduce is written in so many programming languages, but the HDFS is written by Java programming language. This MapReduce with various different optimizations. The purpose of MapReduce in Hadoop is to map each of the jobs, and then it will reduce it to equivalent tasks for providing less overhead over the cluster network and to reduce the processing power. The MapReduce task is mainly divided into two phases. The first phase is map space and the second phase is reduce space. So overall the MapReduce is used for first split and then combined to produce the final result. Also it is used to map each of the jobs and then it will reduce the equivalent tasks. Now in MapReduce we have two phases. One is map space and another one is reduce space. In MapReduce we have several important components. Some of these are: first one is client. The MapReduce client is one who brings the job to the MapReduce for processing. There can be multiple clients available that continuously send the jobs for processing to the Hadoop MapReduce manager. The client is responsible for continuously sending jobs to the processing. And job. The MapReduce job is the actual work that the client wanted to do, which is comprised of so many smaller tasks that the client wants to process or execute. This job is done by in a very less time because we want to, which is comprised of so many smaller tasks. So this job process is run in a smaller time. Now the other important components are Hadoop MapReduce master. It divides the particular job into a subsequent job parts because we have to process the data in a small amount of time. So this MapReduce master is responsible for reducing the time. The subsequent tasks are then assigned to various data nodes in the Hadoop cluster for parallel processing. Here parallel processing is nothing but it is a combined processor in a parallel manner, allowing for efficient handling of large scale data in processing tasks. Job parts. The tasks are jobs that are obtained after driving the main job. The result of the all job parts combined to produce the finals. These job parts are nothing but it is a dividend from the main job. These job parts are combined to produce a final result. Now the other important component is input data. The data set that is fed to the MapReduce for processing. It includes the initial informations and parameters required for the specified computation tasks. It is nothing but it is a input data processing. And other important concept is output data. The final result is obtained after the processing. It comprises the computed outcomes, summarizes, or data transformations generated by the MapReduce tasks. It is this output data is responsible for comprise the computed outcomes and summarize the data. Now we have to move to the next topic. So we all have what is big data and what are the tools and some of these. So we have to find how the big data are come from or where the data come from. So in this topic we have to discuss all about the sources of the big data. The first one is social media. Social media platforms like Facebook, Twitter and Instagram serve as expensive sources of big data, continuously generating a deluge of information through user interactions, posts, comments and shared multimedia content. This comprehensive data set embodies diverse aspects of users' behavior, encompassing preferences, interests, and sentiments, thereby providing invaluable insights for business, aiming to comprehend evolving consumer trends and market preference. Analysis of the frequency and sentiment of the customer comments on social media posts, for instance, offer critical perspective on customer satisfaction and brand perception. By discerning customers' sentiments and preferences, businesses can adaptively tailor their marketing strategies, product offerings, and customer engagement. It is easy to effectively meet customer needs and expectations, thereby fostering stronger brand loyalty and a competitive edge in the market. Now we have to move to the second source of big data, that is IoT devices. The IoT devices, IoT stands for Internet of Things. The Internet of Things devices comprising an extensive array of sensors, variables and smart appliances represent a significant wellspring of big data, continually churning out a stream of data relating to diverse aspects of daily life. These devices generate real-time data on environmental conditions, health metrics, and furnishing businesses, individuals with valuable insights for informed decision making and operational optimizations. For example, within a manufacturing setting, data collected from sensors monitoring variables such as temperature, pressure, and production output can be meticulously analyzed to discern patterns and streamline the manufacturing process, thereby bolstering productivity and curtailing operational downtime. Now we have to move to the next source of big data, that is business applications. Business applications, which encompass a diverse array of systems such as customer relations management platforms, enterprise resource planning software, and transactional databases, constitutes a significant well of structured data in the realm of big data. These applications generate substantial volume of data that offer comprehensive insights into your operational efficiencies, customer interactions, and financial performance. Through the analysis of data originating from these business applications, organizations can gain a deeper understanding of their internal processes, market dynamics, and customer behavior, facilitating the development of informed strategies and streamlined operational workflows to enhance overall business performance. Overall, we have to get the sources of the big data from the day-to-day applications like social media or IoT devices. IoT devices are nothing but like smart watches, wearable bands, yeah, and business applications such as we have many business applications for analyzing and processing the customers' data. These are the some sources of big data. Now we have to move to the thank you. We have end of this session. Hereafter we will see about MongoDB. Contents about MongoDB, definition of MongoDB and architecture of MongoDB, also key features of MongoDB. In this topic, we are discussing about MongoDB and what is MongoDB. MongoDB, a dynamic and versatile NoSQL database. It has transformed the landscape of data management in the modern era, offering unparalleled flexibility and scalability because MongoDB follows the unstructured NoSQL database. MongoDB has become a go-to solution for businesses aiming to efficiently handle complex and diverse data sets. Its document-based data model has revolutionized the way of organizers approach data storage and retrieval, allowing for the seamless management and structured. It allows structured, semi-structured and unstructured data. Leveraging its open source foundations, MongoDB has quickly gained prominence in the tech industry, emerging as a powerful tool for developing high performance applications that demand agility and scalability. In this presentation, we will explore the fundamental aspects of MongoDB, shedding light on its architecture, key features, and diverse the cases, and the evolving trends shaping the landscape of contemporary of management. Architecture overview. MongoDB's architecture comprises crucial components that work in tandem to manage data efficiently and ensure seamless performance. The core components include the Mongo process responsible for handling data storage and retrieval, the Mongoose process facilitating sorting and routing operations, and the config servers storing metadata and configuration details. Data is stored in BSM format, a binary representation of JSON documents, allowing for the storage of complex data structures and types. MongoDB is used for storing complex data structures and types. MongoDB organizes data into collections which act as a containers for individual documents, each representing a specific data record. In this topic, we will discuss about the architectural overview. After this, we will see about the key features of MongoDB. Evolving data models. First key feature is evolving data models. MongoDB's dynamic schema allows for the seamless adaptation of data models as business requirements. Without the need for complex schema migrations, MongoDB allows flexibility without constraints. Developers can work with varying and evolving data structures without being bound by a predefined schema, enabling the storage of diverse and rapidly changing data types. The next key feature is automatic failover mechanism. MongoDB's replication features ensure high availability by automatically electing on a new primary node in the event of a failure, minimizing downtime and ensuring continuous data access. The next feature is data redundancy strategies. By maintaining multiple copies of data across all the different nodes, MongoDB protects against the data loss and enhances data durability, providing a robust and reliable data management solution for critical applications. These are some key features of MongoDB. There are several features of MongoDB, but this is the main features of MongoDB. The next is important feature is aggregation framework. With an extensive aggregation framework, MongoDB enables users to perform advanced analytics and data processing tasks such as grouping, sorting, and performing statistical operations on data sets. The next feature is indexing operations. MongoDB's efficient indexing mechanisms enable users to optimize query performance by creating indexes on specific fields, speeding up data retrieval and enhancing overall application performance. These are some important key features of MongoDB. Conclusion. In the real world, we will face a lot of problems of managing complex data types. But here is the solution. But what? The MongoDB is one of the best and most usable by the digital era. This MongoDB is used for our large scale applications, for our entire applications. There are many other key features are available in this MongoDB, but some features are most underrated. Conclusion. In the real realm of big data, MongoDB stands out as a dynamic and powerful solution, equipped with a plethora of features that cater to the evolving needs of modern data management. It is flexible schema design, high availability through replication, robust querying capabilities, support for secondary indexes, and the integration of geocacheable data make it an ideal choice for businesses dealing with large and diverse data sets. MongoDB's ability to handle complex data types and scale horizontally ensures that organizations can seamlessly adapt to changing data requirements. While it's a comprehensive support for various use cases, reinforces its positions as a versatile and efficient NoSQL database. As the landscape of big data continues to expand, MongoDB remains at the forefront, providing a reliable and scalable platform for businesses to harness the power of data and drive the innovation in their respective industries. It is used to high availability through replication because it provides a robust querying capabilities, support for secondary indexes, and the integration of geoplastical data. MongoDB's ability to handle complex data types and scale horizontally ensures that organizations can seamlessly adapt to changing data requirements. This is all about the MongoDBs. Thank you.